Hi everybody, we're just going to look here at a slightly more complex example of a simultaneous equation with the quadratic. This is only for higher pupils, so wouldn't be on the foundation. You'll be looking at this coming up towards the back of the paper as well. So we'll go through the first process again. Here we need to rearrange it to make either x or y the subject. It actually doesn't matter what I make x or y here, so I'm actually going to make y the subject, and it's going to become y is equal to, so this x goes over here, and it'll be 5 minus x that I'm looking at. So that's your first mark. From here, what I do is I take that, and I'm now going to change y for that, which means I'm changing that y value to 5 minus x. So I'm saying x squared plus my y value, which is now 5 minus x, all squared, is equal to 13. So I've taken that new rearrangement and substituted it into the top. Let's go through that process fully. So x squared plus 5 minus x brackets 5 minus x is equal to 13. I suggest you write this out fully so you don't make any mistakes when you're expanding it. If I expand this, I end up with 25 minus 5x minus 5x, and then this becomes plus x squared. We've still got our x squared there, and we've still got our 13. So from here, what I now need to do is tidy this up. So I've got an x squared and x squared, which gives me 2x squared. And then I've got minus 5x, which is minus 10x, plus 25 is equal to 13. Now, if you think back to solving solving quadratics, what do I need to do? Well, hopefully you understand, you remember that it must equal 0. So this plus 13 has to go over the other side, and it becomes a minus 13. So I end up with 2x squared minus 10x plus 25 minus 13 is now equal to 0. So I've picked up another mark at least, possibly even 2, for substituting up the top and then making it equal 0. Tidy that up again. So I'm going to come over here on the left hand side. So I now have 2x squared minus 10x, and then 25 minus 13 gives me 12 is equal to 0. Okay, a couple of things you can do here. You can either look at the video I did about factorising quadratics when x squared is greater than 1. So I could do my a value times by my c value to get 24, and I look at two numbers that multiply to give me 24 and add to give me minus 10. Or the nice thing about this quadratic equation here is that all of this does divide by 2. So if the number all divides by whatever's in front of x squared, you can just say, right, well, that becomes x squared minus 5x plus 6 is equal to 0. And now I look at factorising here. So two numbers that add to minus 5 and multiply to plus 6. So looking at that, I'm now going to have an x in both brackets. What numbers add to give me minus 5 and multiply to 6? Well, at the end of the day, there's only a couple of numbers that multiply to 6. So 1 and 6 and 2 and 3. So looking at these two factor pairs of minus 1 and 6, because my value here is a positive and my value here is a negative, both of my numbers are going to have to be negative. So if you thought about it, you go, right, well, minus 1 and minus 6. Well, minus 1 minus 6 makes minus 7, so that can't make my minus 5. But minus 2 and minus 3, well, minus 2 minus 3 is minus 5, and minus 2 times minus 3 is plus 6. So this is going to become minus 2 and minus 3 is equal to 0. So solving this, x minus 2 equals 0, or x minus 3 equals 0. So x is equal to plus 2, because I'm taking that over, and x is equal to plus 3. So I've now found my x values. From here, what we now need to do is go back to my initial value for y, because I need to find y now, and I say that y is equal to 5 minus x. Well, in the first instance here, I'm saying x is 2, so it becomes 5 minus 2, which is 3. So when x equals 2, y is equal to 3. So I've done that one there and that one there. And then if I take the next value of x as 3, I'm saying y is equal to 5 minus x, 5 minus 3. So 5 minus 3 is 2. So y is equal to 2. So when x is equal to 3, y is actually equal to 2. Now, you can see there that the values are opposites to each other, and I'll just show you why this actually happens. I'll show you why those points are the correct points now. If you look here, what we can see is that the two coordinates are 3 and 2. So I've got my two lines here. The red line is the x squared plus y squared equals 13. The blue line is the rearranged version of y equals 5 minus x. And you can see that the 2 points where they meet, x is 3 for that first point in the bottom right, and y is 2. And then the second point where they meet, x is 2 and y is 3. So your two x values are 3 and 2, and your two y values are 3 and 2, and that is exactly why. Okay, hope you found that useful, guys. If you need any more information, go back over the videos, rewatch them, but hopefully that'll help you and make it clear as to how we solve quadratic simultaneous equations algebraically. Hit the like for me, and I'll see you in the next video.